Alright, so as we look at today's do now, we want to make sure that we recognize the difference between these two problems. The figures are exactly the same. The difference is that this one asks for volume, this one asks for surface area. So when we're finding the volume, remember our equation for volume is that we are finding the volume is equal to, for prisms, the area of the base times the height. So there's a lot of different ways you can look at which is the area of the base, which is the area of the height, which is the height. So I'm just going to go ahead and say that this top part that they've got shaded in is going to be the area of my base. So the area of my base, since it is a rectangle, would be base times height. So 11 times 6.5. And as we do that multiplication, we're going to get 71.5. Alright, so we can pull that into our equation here, 71.5 times the height, so that's going to be the distance between the two bases. Our second base would be down here, so the distance between the two bases would be this measure. Alright, so we get 71.5 times 10 as our height. As we come over here and look at the surface area, surface area would be 2 times the lateral area times 2 of the area of the bases. So my lateral area is kind of as drawn out on net, this big long rectangle, which I can write out as 35 times 10. Each of the bases, that's the same as the way we had it before. So lateral surface area is 35 times 10, that big long rectangle, 2 times the area of the base, and this is what we would get. Alright, let's flip on over and write down our aim for today. Alright, today's aim, Kipsters will be able to solve surface area and volume problems. So we're going to be combining a lot of what we've done for the past 2 weeks, and we're going to solve some problems that involve both. Alright, Jay has a small fish tank that is the same size and shape as the rectangular prism shown in the do now. The box it came in says that there's 3 gallons in the tank. Is this claim true? Explain your reasoning. Actually, I want you, before we go ahead and look at this, go ahead and read all 4 of these questions here, A, B, C, and D, which seem to be labeled a little bit out of order. Determine which of these problems are talking about volume and which of these problems are talking about surface area. Make sure that you've decided for yourself which ones are volume and which ones are surface area. Alright, so this one is talking about how many gallons it is, which also relates to cubic inches. So this one is talking about its capacity, how much can fit into it. So this one is definitely talking about volume. The pet store recommends filling the tank with 1.5 inches from the top. How many gallons? Again, talking about our capacity. So this one's definitely a volume. Alright, covering the sides of the tank with a background picture. Alright, our answer here is square inches. So this one's definitely talking about those flat surfaces. It's not quite talking about all of the flat surfaces, just the back, left, and right sides. But that is talking about some form or fashion of the surface area. And the last one is talking about how many gallons it's going to take to refill the tank after some of it has evaporated. So once again, we're going to be looking at a volumes. All right, so go ahead and work through each of these problems. Notice this hint that it tells you how many gallons is equivalent to how many square inches is used throughout. If you need to go ahead and redraw the shape from the previous problem, I would highly suggest that you do that and label it. and then go ahead and try and complete each of these individually. I'll go ahead and go through each problem individually, and then allow you to kind of pause and check in as needed. All right, so this first one is talking about the total capacity of the tank, which means you've actually already found the volume, so you can go ahead and use that to help you determine out the work. So if we wanted to go through all of the work on this one again, we knew the volume is equal to the area of the base times the height. The area of the base was the 11 times 6.5, which was 71.5. In this case, it does matter which one we're talking about, the area of the base, because in the future, when we're thinking about surface area, we need to know what's the top and the bottom. Times the 10. The volume is equal to 715 times 10. And so we know the total volume is equal to this many cubic inches, and we want to know what that is in gallons. So 715 divided by 231 is going to tell me how many gallons. And this is going to be approximately 3.09 gallons. So is the claim true? Well, yes, for the most part it is true. I think if you rounded that to the nearest tenth, you'd end up with 3.1. So that's pretty close to true. All right, the pet store recommends filling the tank within 1.5 inches of the top. How many gallons of water will the tank hold if it is filled to the recommended level? So that means we're slightly changing the volume of what we're talking about. So go ahead and work through this problem, thinking about how high the water would be and what the new volume would be if the tank was only filled to 1.5 inches off the top. So looking at this, our new volume would look like this. Our volume would be, now it would only be, instead of 10 inches tall, it would be 8.5 inches tall. The area of the base would remain the same. So area of the base is still equal to 71.5 cubic inches. And so our volume now would be, the volume of just the water would be equal to 71.5. And now the height is only 8.5 inches. So as we calculate that out, we get 607.75 cubic inches. But again, this asks how many gallons. So I need to take that 607.75 divided by the 231, and that's going to give me approximately 2.63 gallons. Alright, coming over here to the next one. This is now talking about Jay wants to cover the back left and right sides of the tank. So now, again, we talked about this before. This one's talking about some area here. It is not talking about the full surface area, though. So it might be helpful to draw out only the surface areas that we're talking about covering here. Go ahead and work on this one and come back and check in. So when I look at this one, I think about the back, left, and right side. So I think about the back is going to be a 11 by 10, and then the two sides will be 6.5 by 10. So when I look at this, I think about this as one big long rectangle. Now you can find the area of each individual rectangle and add them all together, But I'm going to treat this as if it is one big long rectangle. So this area would be equal to the base times height of this big long rectangle. 6.5 plus 11 plus 6.5 would be my total length of this entire rectangle. And when I calculate that, that's going to give me 24 inches. So my area of my base is 24 inches times 10, which would be 240 square inches. All right, the last one says the tank evaporates each day, causing the water level to drop. How many gallons of water have evaporated by the time the water is 4 inches deep? The time the water in the tank is 4 inches deep. All right, so assume the tank was filled to 11.5 inches, or to 1.5 inches off the top. So when we think about this, there's a couple of different ways to do this. I'm going to draw out a sketch here. You can think about how much volume was in there, how much volume is left, and do a subtractive method. Or you can just find the volume of what was left over. So when I think about this, I'm going to think about this as this part, which was what it was filled up to, that's 1.5. And now where we're being left at is 4 on the bottom. The whole thing originally, from top to bottom, was 10 inches. So what's left over here in the middle, this would be the part that evaporated. So this would be the part that I'm talking about. It would be this part in the middle. So I want the volume of just this middle piece. That's the way I would solve this problem. So the area of my base is still equal to 71.5. But now my height is 4.5. So the volume of the evaporated part is area of the base times the height of the evaporated part. So 71.5 times 4.5. When I get that and I go ahead and do that calculation, I get 321.75 cubic inches. So to determine how many gallons, I need the 321.75 divided by 231. And that gives me approximately 1.39 gallons. All right. So that's all of these problems. Flip on over to the other side. There's some more problems to look at. So in these problems, we're giving two fish tank designs. One has a trapezoidal base, one has a rectangular base. Which tank holds the most water? So we need to find the volume of each. Remember, in order to find the volume, you're going to need the area of the base times the height. So volume R and volume T are both going to be equal to the area of the base times their height. But remember that they have two different bases here, so you'll have to find the area of this base first, along with the area of the rectangular base first. You can break this apart into a rectangle and two triangles if you wish, in order to find the area of that base. So go ahead and work through this problem. Find the volume of each of these shapes and tell me which one is greater. Alright, so for the rectangular one, the area of the base I'll just kind of do this work off to the side here. The area, actually I'll do it right here. Area of the base is equal to base times height, which is 25 times 10, which is 250 square inches. So 250 square inches times the height, which is 15. My volume for this one would be 3,750 cubic inches. All right, for this one, the area of the base is equal to the rectangle, the area of the rectangle, plus 2 times the area of the triangle. The rectangle would be 25 times 8, plus 2 times 1/2 of the base, which would be 6 times 8. So really 2 times 1/2, that's just 1, so really just the 6 times the 8. So this is going to be 200 plus 48. It's 248. So my volume of the trapezoidal one is going to be 248 times its height, which we can see in this case is also 15. Which is 3,720. So they're very close to the same size, despite their different shapes. But in this case, the volume of the trapezoidal is less than the volume of the rectangular. All right, which fish tank has the greatest surface area? Okay, so surface area, we might need a little bit more space for this one. Surface area, we need to find the area of all of these surfaces. Good news is we've already found the areas of the bases, so really we just need to find the lateral areas. Surface area is equal to the lateral area plus 2 times the area of the base. That works for both of these. So surface area of the tank, the trapezoidal, and surface area, we'll do the rectangular here, and surface area of the trapezoidal, also here. Right, so our lateral areas, again, we can do that by multiplying, by thinking this is one big long rectangle, 25, 10, 25, and 10. So that would be the base of one long rectangle, and the height would be the 15. So the 25 and 10, 25 and 10 would give me 70 times the height, which is 15. 2 times the area of the base. We said the area of the base coming all the way back up here was 250. So we get 1,050 plus 500 would be 1,550 square inches. All right, for this one, now looking at our trapezoidal area, we want to go the distance around the trapezoid. 25, 10, 25. Okay, this is going to be more than 25 and 10. This is going to be 10. And this back one is going to be 6 plus 25. So that back one is actually going to be 37. So here we're going to have 82 times 15 plus 2 times the area of the base, which we found the area of the base was 248. So we get 1,230 plus 498, and that will give us a total of 1,728 square inches. So in this particular case, we can see the volume of, or the surface area of the trapezoidal is larger than the surface area of the rectangular prism. Alright, so looking at this problem, we need to find the volume of each evaporated. So we're only looking at the volume of the evaporated part, which means we've got a height of 1/2 inch of evaporated water for each of the tanks. Go ahead and use that to find the volume of evaporated water. So looking at this, the volume of the evaporated water would be the area of the base times the height of evaporation, which is 1/2 in each case. Well, the area of the bases we've already found, 250 for the rectangular, 248 for the trapezoidal, and so that's 125 cubic inches for that, for the rectangular, and 124 cubic inches for the trapezoidal. Coming to the next one, it says design at least 3 fish tanks that will hold approximately 10 gallons of water. I've calculated for you that 10 gallons of water times 231 cubic inches means you're trying to find fish tanks that would multiply to about 2,310 cubic inches of space. And it asks you to go ahead and make one tank that has a base that is not a rectangle. So work through this process as quickly and efficiently as you can and create 3 tanks of this size. Once you're done with that, please go ahead and move on to the alone time.